Hi kids. In this video we are going to go over numerical expressions. It is considered our introductory lesson to the concepts related to numerical expressions. And so if you are absent today or you just want to refresh your memory or update your notes, this is the video that you would be watching. Okay? So anyways, we are going to be talking about numerical expressions in this short video. All right? Now, one thing that we want to do is ask ourselves, what is an algebraic expression? Now, there are kind of two answers here, okay? You know, the one is that it is an algebraic expression is a mathematical phrase. Okay, so that is the textbook definition of what an algebraic expression is. An algebraic expression is a combination of one or more variables, constants, and operation symbols. Okay, now this is the textbook definition, but the truth is algebraic expressions were created by humans to be used in real-world situations to explain those situations mathematically. And what they do for those situations is they condense them down from words or just, discussing them into variables, constants, and operation symbols. Now, we know what a variable is because we've gone over variables in class. We know what operations are because we've been doing those since we were young. One of the things that might be new to us is the word constants. All right, so a constant is something that doesn't change from problem to problem. It will remain the same, and we'll go over that. So a constant is something that is constantly there. It doesn't change, okay? Now, when we look at algebraic expressions, they can be broken down into several key parts, okay? So what we're looking at right here is this expression, okay? And the expression is nothing more than 3x plus 5, okay? Now, we don't know what situation this represents. We don't know the value of x, but we know that it is an algebraic expression, okay? Now, one of the things that we want to keep in mind is this. X is a variable, okay? X is a variable. And a variable is a quantity that can change, like, say, the cost of a milkshake. You might go to McDonald's and pay one price for a milkshake, go to Wendy's, pay another price for the milkshake, go to Dairy Supreme and pay another price. So that's why we could use X, or a variable, for the price of a milkshake. Now, in this case, X is undefined, and we could define it and say the value of X is actually 4. Well, in this case, then, we can evaluate the expression and say, okay, well, 3 times 4 plus 5, okay, 3 times 4 is 12, using the order of operations, plus 5 would give us 17. All right, so in this case, once we define what the value of x is, we can then evaluate the expression. Now, in this case, we could also say, well, maybe the x has a value of, say, 2. Well, in that case, you'd say 3 times 2 plus 5. So you have 3 times 2 is 6, plus 5 is 11. So, you can see that what is constant is the 5, which leads us to the definition of what a constant is in an algebraic expression. A constant stays the same, like, for example, the pennies in a dollar. There will always be 100 pennies equal to $1, okay? That is a constant that we work with, okay? Now, over here, we have some other things to think about. So now we know what the variable is and what the constant is. The 3 represents a coefficient. 3 is the coefficient of x. A coefficient is a number that multiplies a variable. Now, in algebra, the operation of multiplication is implied, which means that we will sometimes get rid of the multiplication symbol and just put a number next to a variable or a parentheses. Okay, so it's implied. But something to remember when you're writing algebraic expressions and using coefficients and variables is that it is standard form to write the coefficient or the number on the left side of the variable, okay? And that's just standard issue, even though we know from the commutative property that they would both equal the same amount. This is the standard method in algebra for writing coefficients, okay? So you have the coefficient, and then you have 5 over here, which represents a constant in this case. Now, the coefficient and the constant separated by addition represent terms, okay? So the terms of an expression would be a part of an expression separated by plus or minus. So the part or parts of an expression, such as 3x plus 5, are terms, okay? They are terms because they are separated by addition or subtraction. In this case, addition, okay? Now, together, okay, if we were to throw in an equal sign, okay, there would be an implication that we want to solve or find the value of that expression, okay? And in that case, we are going for an equation, okay? And in this case, they tell us that one side and the other side, they both equal 20. Well, at this point, we still don't know what x is, but we could figure out what x is because we'd be thinking, okay, 3 times some unknown number plus 5 equals 20. Well, in this case, we could say, well, x must have a value of 5 in this instance, okay? Because if we plug 5 in there, we know that 3 times 5 is 15 plus 5 equals that 20. Now, here's the thing. This constant is 5. But again, in a different situation, that x might be a value of 3, and in which case, it would not equal 20. Okay, so you would have a different answer, or you would have an inequality. Okay, it does not equal. All right? So those are the parts of an expression grown into an equation by putting the equal sign in there and giving equal values on both sides. All right? Now, why do we have algebraic expressions? Earlier we gave you the mathematical description of an algebraic expression, but I hinted as to why we have them. Well, the reason we have them is because we have algebraic expressions to explain situations mathematically. The situation mathematically. So in other words, here is a very famous algebraic expression, okay? Base times height divided by 2, okay? So we have base times height divided by 2. This is actually a fraction, which is a division expression. You just happen to have the terms up here. You just happen to have your base times height, okay? So you just happen to be multiplying, then dividing by 2, okay? This expression is very famous because it is used to find, now I'm going to turn it into the equation, A. It is used to find A. A in this case is the area of a triangle, a right triangle, isosceles triangle, and we'll talk more about that. So this is a very famous expression. You have your variables, you have your division and multiplication operations going on in there. And when we join it up and we say it's going to equal area, we're talking about an equation, or what we typically call this, the formula for finding the area of a triangle. Okay? So anyways, now for some more professional information on the subject of expressions. In Schoology, I have posted some videos made by other professionals, about 7-10 minutes of video that you probably should review that gives you some more information on expressions, okay? So anyways, that was our introduction. Good luck. If you have any questions, you can see me in class or ask your parents.